Why do alloying elements make materials creep resistant? Imagine a metal that can withstand high temperatures and constant stress without slowly deforming or breaking down. That's what engineers aim for when they add alloying elements to metals. These tiny additions can make a big difference in how materials behave over time. When metals are used in engines, turbines, or power plants, they face extreme heat and stress. Without proper protection, they can slowly stretch and eventually fail through a process called creep. So how do alloying elements help prevent this? Let's find out. First, alloying elements often form tiny particles called precipitates inside the metal. These particles act like roadblocks for dislocations, which are the main carriers of deformation in metals. When dislocations try to move, they bump into these precipitates and slow down or stop. This process is called precipitation strengthening. Elements like chromium, molybdenum, vanadium, and niobium create carbides or nitrides that stay stable at high temperatures, keeping the metal strong over long periods. Second, some alloying elements dissolve into the metal's crystal structure, causing distortions in the lattice. These distortions make it harder for dislocations to glide through the material. This is known as solid solution strengthening. Elements like silicon and carbon help in this way by creating a more resistant internal structure that resists deformation. The more difficult it is for dislocations to move, the slower the creep process. Third, alloying can influence the formation of different phases within the metal. By controlling which phases form and when, engineers can prevent the development of weak spots that might accelerate creep. For example, suppressing the formation of large carbides keeps the microstructure stable. This microstructural control helps the material maintain its strength even after many hours at high temperatures. Fourth, alloying elements also improve the stability of the microstructure itself. They prevent the precipitates from coarsening or dissolving during prolonged exposure to heat. When precipitates stay fine and dispersed, they continue to block dislocation movement effectively. This stability means the material remains creep-resistant for a longer time. Finally, some alloying elements like chromium add corrosion and oxidation resistance. This means the material doesn't degrade as quickly when exposed to harsh environments. Maintaining surface integrity prevents cracks and voids from forming, which can lead to creep rupture. So, alloying not only helps resist deformation but also keeps the material intact under tough conditions. In essence, alloying elements make materials creep resistant by creating a microstructure that fights against dislocation movement, phase instability, and environmental damage. They help keep the internal structure strong, stable, and resistant to the slow, destructive process of creep. This is why alloys with carefully chosen elements are used in turbines, engines, and other high-temperature applications. They extend the life of these components and keep them working safely for years.